All right, problem 3. We got bath fizzies are mineral tablets that dissolve and create bubbles when added to bath water. And it says, in order to increase sales, the Fizzy Bath Company has produced a new line of bath fizzies that have a cash prize in every bath fizzy. Let the random variable X represent the dollar value of the cash prize in a bath fizzy. The probability distribution of X is shown in the table. Okay, part A. Based on the probability distribution of X, answer the following. Show your work. All right, so here we got calculate the proportion of bath fizzies that contain $1. Now, this is a very interesting company. Now, you can see that the prices, the cash prices go from $1 up to 100, and the proportions below. So, since these, 6 amounts make up all the total prize amounts you can win, their probabilities have to add up to 100% or have to add up to 1.0. So if you want to find what this is, you simply can take all of these values, subtract it from 1. So you basically just going to have 1 minus 0.2 minus 0.05 minus 0.05 minus 0.01 minus 0.01. And you can do that in your calculator or with work by hand, but in either case, you would get that you would have that the probability of getting $1 would be 0.68. All right, part 2. Calculate the proportion of bath fizzies that contain at least $10. Okay, so we want to find the probability. Let's set up a equation. The probability that X is greater than or equal to 10. So we include 10 as well. So then that could include that this, or this, because that's $10, $20, $50, and $100. So you really just have to add up these 4 probabilities. And I'm showing work, that's what it says by showing work. Or it says showing work, so I'm going to assume they want this addition. So just pay attention to that because sometimes they're really strict on that. And this would simply be 0.12. All right, in part B. Based on the probability distribution of X, calculate the probability that a randomly selected bath fizzy contains $100, given that it contains at least $10. Okay, so this is a conditional distribution, so be careful about this detail. So we want to find the probability that a selected bath fizzy contains $100. So probability that X is equal to 100, given that X is at least 10. So you could set up something like this. So the way I just thought of this logically, there's always, we have a couple formulas, but it really comes down to logic. If you're told that you have at least $10, you only then care about these probabilities. Your sample space has, given and reduced these 4 possibilities. So the probability of getting $100 is this value divided by the sum of these probabilities, divided by 0.05 plus 0.05 plus 0.01 plus 0.01, be 0.12. Now it'd be about 0.083 repeating, 8.3 repeating percent. All right, part C. Based on the probability distribution of X, calculate and interpret the expected value of the distribution of the cash prize in the bath fizzy. Show your work. Okay, so the expected value of X, if you recall it, and this is in your formula sheet, is a summation of each of the X values multiplied by their corresponding probability values. So Xi, so we have, let's call that X1. These are your X's times its corresponding probability. This we found to be 0.68. So we'd start off by going 1 times 0.68 added to the next prize amount, $5 times 0.2 times plus 5 times 0.2 plus 10 times 0.05 and so forth. So plus 20 times 0.05 plus 50 times 0.01 plus 100 times 0.01. Oops, not times 50. 50 and 100. So just use your calculator to double check your work. This is a simple arithmetic. 0.68 plus 0.2 times 5 plus 10 times 0.05 plus 20 times 0.05 plus 50 times 0.01 plus 100 times 0.01. 4.68. It'll be $4.68. Now, what does this mean? Well, this is basically saying that if you know, if someone was to, you know, select many of these Bats Fizzies, or, you know, whatever, play this game over and over and over many times, on average, they would get $4.68 worth in prizes. So again, it's a long run frequency. Well, not long run frequency, I guess technically. What you would expect to win if the game was played. I'm not even sure if this is a game. I guess if many of these Bats Fizzies were selected. So we'll write something like that. If many, I like to say if many. Let's mention random in case they're going to be critical about that. If many Bats Fizzies are randomly selected. And the average prize amount won would be about $4.68 on average. Okay, and D, the Fizzy Bat company would like to sell Bat Fizzies in France. So they're expanding their market, I see. Where the currency is euros. Suppose the conversion rate for dollars to euros is $1 equal to 0.89 euros. Using the expected value from part C, calculate the expected value in euros of the distribution of the cash prize in Bat Fizzies. Show your work. Okay, so this one's pretty straightforward. Just don't overthink it, because since this is just a basic summation of, you know, multiplication of these numbers, since $1 is equivalent, since $1 gets converted to 89, or since $1 gets converted to 0.89 euros, that means you would multiply $1 by 0.89 to get the amount in euros. So since this expected value is in dollars, you simply could just multiply everything by 0.89, and you're going to see it's just going to end up being by 0.89. So I'm not even sure how they want you to show your work. I mean, I guess let's say let's put as y equals the amount in euros. And then so y is equal to 0.89x. And then the mean of x, or the mean of y, or the expected value of y, is equal to 0.89 times the mean of x, or the expected value of x. So the mean of y would be equal to 0.89 times 4.68, which would be about $4.1652 euros. All right, and that's really it. That's all there is to this problem, I can see. I mean, I'm pretty confident in my answers, and I'm pretty confident that I would get full credit on this. This one actually didn't seem like a tough probability this year, but we'll be sure to check when the official solutions come out, which will probably be in like June or July. But also let me know if you have any questions. And just again, I'll look for any corrections I may have missed, and I'll put them in the comment section. But other than that, go ahead and check out the other videos I'm going to be putting up, the other 4, 5, and 6 after this one.